Okay, welcome back. So we just talked about how to make, how to simplify a fraction when the exponent is negative. We said that we want to move it to the top. In this case, I really don't like this example because it's making it negative. So actually I'm going to write it this way. X negative 1 would be 1 over x to the n power, because I simply would put a 1 here and then I would flip and multiply. Okay? So this would equal here. Okay, now we're going to cover zero exponent. The zero exponent, what that means. So if you look on the bottom of page 122, we know that a non-zero number divided by itself is always going to be 1. So for example, if I were to put 4 squared over 4 squared, I know that equals 1. We've always known that. That's no different than saying 4 divided by 4. So anything divided by itself is 1. This is what this is saying. Why that's important for us is because it's going to help us to understand a concept, okay? The zero exponent concept. If I were to take 4 squared over 4 squared, and this time I were to take the 4 squared and move it to the numerator, okay, this would look like this. It would say 4 squared right here. But this time I'm going to take the denominator and I'm going to move it to the numerator. So I'm moving it to the top, okay? And I'm going to say times 4 negative 2. I have to change it from a positive to a negative because I went from the top to the bottom. And that's why the product, or the exponent, I'm sorry, not the exponent rule, what do we call it? The definition for the rule was stated the way it was. So going back to page 129, where it says the definition of x negative 1, that's why they wrote it with 1 over x to the n equals, put this in the numerator, x negative n. It's showing you that when you move from one part of the fraction to the other, it changes the sign. This is what happened. We had a 4 squared, it made it a negative. Now, following our rule here, we know that when the bases are the same, you're gonna add these. So 2 plus a negative 2 would be a 0, and 4 to the 0 equals 1. We just proved our theory here. When you take a number divided by itself, it is 1. How do we know that? Because if we take the denominator, move it to the top, it becomes a negative. 2 minus 2 is 0. So this expression will always be 1. It doesn't matter what the number is. The number could be 200 to the negative, I'm sorry, it could be 200 to the 0 power, that's going to be 1. It could be x to the 0 power, that's going to be 1. Anything, any base raised to the 0 power will always be 1, and we just proved why that's the case. Okay, so moving on to the distributive property using these rules. Okay, so we're going to take a look at number, let's see, number 29.7. Okay, 29.7 says, okay, we have x to the 5th, y to the 0, z, p to the negative 3rd, z to the 0, minus 4x to the negative 5th, z to the negative 1. Again, it's really important that you follow whatever the directions tell you. It says to use the distributive property to expand. It does not say anything about making everything positive. That's important because in another lesson, we're going to have to do that step. Okay, so we learned that anything to the 0 power equals 1. That means this expression reads x to the 5th times 1 times z. This reads p negative 3rd times 1 minus 4x to the negative 5 times z to the negative 1. That's important to remember. To begin with, let's put a 1 on every variable that does not have an exponent. That is because we're going to remember that the distribution property means we have to multiply this term, the coefficient, we have to multiply it to each term inside. This one has two terms. We know that because there's only one negative sign separating. It doesn't have to be negative, it's just that there's a sign. If there was another sign here, like +4, that means it would be 3 terms, trinomial, okay? So let's multiply these using our rules. Looking for the same base, we're going to multiply these out. The easiest way to do this is to say, write all of the letters here together. When you write letters together, remember they mean multiplication. So X, Y, Z, P, and Z. X, Y, Z, P, and Z. There we go. Now we're going to put our minus sign, and we're going to do it again. We're going to say, I'm sorry, before we do the second part, let's go back. Now, over here I have 5 X's, and over here I did not have any, so this stays a 5. I'm adding. This one had 0 Y's, and there's no other Y's in here, so this stays 0. This had Z to the first, that's 1 Z, and that's another Z, so 1 plus 0 is 1. Out here there are no P's, but there's a P here. It's a -3, so I'm going to bring that down. Over here you have Z to the first and Z to the 0. Now we've already written that down, so I'm going to take that off. So actually I didn't have to write that second Z. I should have realized that because I had already written a Z. I didn't have to write it twice. So what I should have done is only write down one set of X's, one set of Y's, one set of Z's, and one set of P's. And then go back and count how many you have, and then write those down. Okay, now let's do it again. We're going to write one set of X's, actually our coefficient of 4 first, so -4. Then we're going to write down one set of X's, one set of Y's, one set of Z's, and go back in here and make sure there's no other letters. There are not. X here and Z here, okay? Then we're going to add. So we have X to the 5th, X to the -5th. So 5 minus 5 is 0. Y to the 0, there are no other Y's, so this stays Y to the 0. This is Z to the first. 1 minus 1 is 0. So there, this is now simplified. Now I'm going to go back and I'm going to simplify it further by remembering that you're going to put everything in the right order. So we have P to the -3rd, do this alphabetically, okay, P to the -3rd, and then we're going to have X to the 5th, Y to the 0, but remember anything to the 0 power is 1, and I don't want to put a 1 right there, that would be awkward. So I'm not going to do that. I just don't need to bring the Y to the 0 down. It's already simplified. And then I bring down the Z. So this is P to the -3rd, X to the 5th, Z. Minus 4. And then X, Y, Z, we got lucky. This is already in the right order. So X to the 0 power is 1. Y to the 0 power is 1. And Z to the 0 power is 1. Those are all 1. But we don't want to say 4 times 1 times 1 times 1, so we don't even need to write those down. Those are already simplified. So the expression reads P to the -3rd, X to the 5th. This is a Z, looks like a 2, so I'm going to change it, and then -4. This is not a simple concept, you guys, so you actually have to watch this video a couple of times and really do it step by step. You may, or most likely, you're going to need some help, so go ahead and give me a call or Skype and I will walk you through the process. I don't have time on the video to do any more examples, but they're pretty much the same, so if you have any questions or need help with any of them, let me know.